Okay, compound interest is interest that's paid on the interest as well as the original amount. So what this means is, remember when we did simple interest, we were calculating the interest just on one principal amount. Now, what this means is, let's say after a month, you calculate how much interest you earned. Like if the interest rate was, let's say, 3%, then after a month, you would gain interest on the original amount, the principal that you put in, plus the interest that you had already earned after a month. And then the next month, you would earn interest on the original principal amount, plus the interest that you earned from the first 2 months. Does that make sense? So each month, and I'm just using the example of months, but it could be years, it could be weeks, it could be depending on what the situation is, you would keep gaining interest off of the principal, but also off of the interest that you had earned. That's why it's called compound interest, because it's being compounded each time. So I just figured it would be helpful if we use this original interest formula, I equals PRT. So that's our simple interest where you earn the interest or calculate it once. And then we could compare it to this new formula, compound interest. Then the reason that I've drawn them like this is so that we could compare them to each other and recognize that we have a lot of the same variables that we're working with. So notice down here in our compound interest formula, we have A. What does our A represent again? Because it's been a while. Do you remember what we call that, the A value? Pardon? Future value. Yeah, we called it future value. We sometimes called it final amount. Does that sound familiar? And final amount I like using because then the A kind of makes sense, right? So either of those is fine. Equals P, which is this principal amount, the stuff in red. That's the same for simple interest and compound interest. That's just what you're putting in. And then in this formula, we also have this 1 plus R over N. And R is still the same annual rate that we used last day in the simple interest formula. So remember, if it's given to you as like 2% or 3%, what do we do to use it in our formula? We would convert it into a decimal, right? So remember that that's always the first step. And then here's the part that sometimes throws people off a little bit. The N value that's here, we haven't seen that before. The N value is, I'm going to move this up, it's the number of times the yearly interest is compounded per year. I think this will make a lot more sense once we actually get into some examples. And you can see how that N value shows up and how we plug that in. So if it tells you that you have some interest rate where the interest is being compounded monthly, what would the N value be? If it's compounded monthly, the N value would be 12. Make sense? If it's compounded twice a year, the N value would be 2. So that's all that means. And I'll show you with an example. And then the T is still the same old T that we were using before. It's always calculated in years. So remember that if it's not given to us in years, we do the calculations in the first step to convert it into years. So I know that as of right now, this formula probably looks a little bit confusing, probably looks a little bit intense, so that you know this formula is also used in grade 12. Jasmine, do you remember this? Yeah, so this is, I feel like, wow, I can't believe that we're doing this in grade 9, but it's good to be introduced to it. We'll keep it fairly simple, the numbers and the values, and that way it's good because when you see it in grade 12, you'll be familiar with it or you will have seen it before. Okay, I think the best way to really learn this is to dive right into an example. So let's do this first example together. It says, find the interest earned if $7,400 is deposited. So if it's saying 7,400 is deposited, what do you think that that is? Which of the variables? Yeah, that's going to be our p-value. So I feel like organizing and gathering this information will make things a little bit easier for us. I'm even going to start filling it into our formula up here. So for p, I'm going to put in 7,400, and that allows me to check that off. In the formula, this 1 plus is always going to be 1 plus. That's because that 1 accounts for the original amount plus the interest that's earned on it. That's why that 1 is in the formula that originally stays there. Okay, then it says in an account paying 5%, how do I plug that in and which variable do I plug it into? Into R, and what's R going to be? Good. Are we all okay with that and understand the reason we do that? So in our formula, we're going to have 1 plus 0.05 over, okay, at the bottom we have our n value, and here it's telling us it's compounded monthly. So what do I fill in for my n value? We're going to plug in a 12 here for our n value. Okay, and then also in our formula, notice there's an n value up there, so I'm going to plug in a 12 there. And it's times t, and in this formula, what does it tell us that t is? 4 years, so we're going to multiply this by 4. And that all would tell us our A value, our final amount, or our future value, whatever you want to call it. So, Ashan? The 12 is because of the fact that here it says it's compounded monthly, and we know that we're interested in how many times it's compounded in a year. So if it's monthly, we know it's 12 times a year. Good question. Good? Okay, the next step, which can also be a little bit tricky, is how to punch this into our calculators, because can you imagine doing this by hand? I'm not expecting you to do this in your mind, or using your mind and not a calculator. So to speed things up, let's plug this in using our rules of bed mass. Which part do I have to do first? The division inside the bracket. So remember bed mass, we would do the brackets first, and even within the brackets, we would do the division first. So 0.05 divided by 12 is what we want to do. So you can punch that in, and then you can add 1 to it. So to work our way through this, I'm just going to write it down so you can clearly see in your notes what we're doing and where we're getting this from. Do you see that we get around approximately 1.004? There's more digits after that. It says 1, 6, 6, 7, da, da, da. So I can round it to about 3 decimal places. I looked past the 4 and noticed there was a 1 there. That's why I just rounded it down to 4 instead of up to 5. Are we good with the rules of rounding with that? And then to the power of, what is 12 times 4? Yeah, so it's going to be to the power of 48. Do you see we can multiply those two to clean them up a little bit? So we're sort of doing a lot of stuff all in one question. This is all the rules of bed mass, right? Okay, so then what would we do next? Bed mass. Which part would we have to do next? Real? The exponents, right? So we would want to do, and now I don't know if you've done this before, and this is going to be different on each calculator. On your calculator, you would punch in 1.004, and then some of you might have a button that says y to the x on it. That represents the exponent key, and then I would punch in 48. So some of you, this is the order you would punch it in. If you don't see that, some other calculators instead have a button that looks like that. It looks like the tip of an arrow. That's also used for the exponent key. You would punch in 1.004, Actually, maybe I should write that there, 1.004, then this, and then 48. And you should get around 1.2112066. 1.221, we'll say. Does everybody get that and know how their calculator works? Okay, how about this? If you're shaking your head, that's totally understandable. I think the easiest way is Jasmine and I will afterwards come around to you individually. So for now, if you haven't figured out your individual calculator, don't worry about it. Skip that step and we will come around to you individually to help you with that. That's probably the easiest way because there's so many different calculators and different methods. And then once we show you, maybe make a note in your notes so that you know for next time how your specific calculator works. And after doing that and multiplying it by 7,400, we get $8,962.93 for our final amount. Okay, so I know that calculation part is a little bit confusing because we have to navigate and figure out your calculator. So don't worry, we will do that one-on-one afterwards. But we actually haven't answered the question yet, have we? It says find the interest earned. Find the interest earned. What did we find here? What is that? Alex? Sorry? That's the total amount. So what's a smart way for us to just get the interest? Yeah, Alex, you can continue. Yeah, that minus what? Yeah, that minus the 7,400. Because, does everybody see the 7,400 was the principal amount? So once we've calculated the total, if we subtract that out of it, it's going to leave us with the interest, which when we plug it into our calculator, we get $1,562.93 is the interest earned. I'm taking a shortcut and just throwing it into a sentence right from there. But do we understand that calculation and the reason why we subtracted off that $7,400, the principal amount? So just make sure when you're done with your calculations that you do go back and you do ensure that you've actually answered the question that they were asking. Good? Yes, Elise? Yeah, so always with word problems, we'd write a sentence at the end to show that you know what it is that you've calculated and also to make sure to double check that you did actually answer the right question. Yeah, good? So it doesn't have to be super long and complex, just a little quick blurb to show what it is that you found. Good? Okay, on to the next one. What initial investment is needed to become a millionaire in 20 years if interest is 10% compounded quarterly? Okay, this is interesting. We'll go through this together. What initial investment is needed? What initial investment is needed? Which variable is it asking for? It's asking for P. What initial investment is needed? Make sense? So that's part of this is understanding what the question's even asking for. To become a millionaire. Okay. If it's saying to become a millionaire, well, how many zeros does a million have? Yeah, so 1, 2, 3, 4, 5, 6. And what where would I plug that into our formula, or what variable would that be? That would be our A. Is that good? And everybody understands the reason for that? So do you see how this is sort of like figuring out a puzzle? We have to read it and even figure out what's given to us, what are we looking for. A lot of it is organization. So that's the first step in what we're doing right now. In 20 years, which variable would that go into? That's going to be our T, right? It's already given in years, so I don't have to convert anything. I can just take T equals 20. Okay, the interest is 10%. Which variable and how do I plug that in? R equals what? 0.1. Thank you. Everybody good with how we got that? 10% means 10 out of 100. That's how we got the 0.1. And then we have this other thing here, compounded quarterly. And I'm out of different colors. I'll try to use that. Oh, that one doesn't show up so well, but whatever, we'll try it. Compounded quarterly, which variable and what do I plug in for it? N. And if it's compounded quarterly, what is my N value? 4. Everybody good with that? You know quarterly, like think of a quarter. There's 4 quarters in a dollar. A quarter of something is 1/4, right? So it makes sense that the value would be 4. Okay, so that's just us getting organized and figuring out what's what. The next part, as always, is plugging things into our formula. Does this sound reasonable? I think it's reasonable given everything going on that I give you the formula for compound interest. So I'm not going to expect you to memorize it. Let's write it down so you can see it in front of us and start to fill in the different parts. I think naturally you probably will start to memorize it once you plug it in a few times, but this is not the time to take chances. I will give that to you whenever you're working on this stuff. Good? So let's start to fill things in. Our A value is 1,000,000. So 1, 2, 3, 4, 5, 6. That's a lot of zeros. Equals our principal amount. That's what we're looking for. So I'm going to leave that there. 1 always stays out as 1. The reason for that is because it's like 1 being multiplied by the principal amount. That's the reason. That's how it just gives us the final value right away. Plus R, which is 0.1, over our N value, which was 4, times, to the power of the N value again, which is 4. And I'm going to use that pink because this thing's not turning out so well. Times our T, which was 20. So the hard part is sorting through the information and checking to see that you know what you're looking for and what you've got. And then the rest of this, do you see we're sort of repeating the same pattern? But this time, the answer is given. We're working backwards to find P. So the calculations will require a bit more thought. Do you have questions about this so far? Are we all good with how we got that? Okay, so which would be the best, what can we start to simplify already? The 0.1 divided by 4? Sure, let's do that first. So 0.1 divided by 4. Then we have to plus 1 to it. So we can start to clean things up a bit. The color coding is really slowing me down, but that's okay. I can still do that. I was going to try to skip that. In our brackets here, we would get 1.025. Everybody okay with how we got that when we dealt with all this? To the power of, is there a better way that I could deal with that stuff? To the power of 80. Everybody good with that? And then we still have 1, 2, 3, 4, 5, 6 to make 1,000,000 on the left side. Okay, lots of stuff going on here. What can we do next, or what should we do next? To the power of 80, that is a huge number. Okay, so when we do that, we get P times, when we do all of this to the power of 80, we get 7 I'll write it in brackets, 7.209,568. We could simplify that, like we could round it to, let's say, here or here, but that's okay. I'll just write them all down. Equals 1,000,000. And we want just P, and we know algebra is all about opposites. So to get P by itself, how do I get rid of this 7.2 Kira? Yeah, divide by 7.209,568. Why didn't I just round that? That's okay. 7.209,568. It actually is best for us to leave the rounding for as long as we can to make it more accurate, but I'm okay if you round it earlier. So when we do that, do you see that these cancel and just leaves us with 1? That's the whole reason we even do that. So on the right side, I would just have P, and that's what I want. And on the left side, when I divide this all out, I end up with a principal value of $138,704.57. Maybe a comma there would help to put this into perspective. So you would need to invest, because do you see that P was the principal amount? And if I go back to the question, it says, what initial investment is needed to become a millionaire? So you would need to invest this amount, $138,704.57 to become a millionaire. Make sense? So these are a lot of different types of questions. Your assignment, your questions that you can work on for today is page 67, numbers 1 to 2. You're going to do the odd letters. I haven't done that in a while. Do you remember what I mean by that? A, C, E, like you skip a letter just to do every other letter. You can do 3 to 6, 9, and 11 to 16.